from today's discussion on sampling methods, there's two things we have to be able to do. The first one is we have to know the difference between the sampling methods, when you would use them, what are the benefits, what are the drawbacks, and then we're also going to have to be able to actually carry them out. The first sampling method we already talked about is a simple random sample. So that's SRS. To remind you, simple random sample is when every sample has a chance to be chosen. So if I want to know the average amount of time that students spend on homework at Prospect High School, and I take a sample of 10 freshmen, 10 sophomores, 10 juniors, 10 seniors, is that a simple random sample? No, why not?
You take 10 of each.
Okay, what is a sample I should be able to get that I can't using that method? Adam?
Like all freshmen.
All freshmen. So all freshmen should be an option. Because it's not, that's not a simple random sample. The reason that we generally take simple random samples is it's the best way to get a sample that is representative of the population. So theoretically, it's possible if I take a sample of size 40 that I'm going to get all freshmen. It's not very likely, though. So it's the best way to get a sample that is representative of the population. And here is the key to why we need that. You need a simple random sample to generalize from the sample to the population. So we've talked about the reason we don't take a census is we don't have the time, we don't have the money. Occasionally the process is destructive, so we take a sample with the hopes of generalizing to the whole population. We can only do that, though, if it is a random sample.
Could you not generalize a stratified sample to the population?
Correct. Well, you can if it's random, if it has some type of random process, but generally we're looking for a simple random
10,
sample.
10, 10, 10, if you randomly selected the 10, you couldn't generalize that?
You can. The preferred method is a simple random sample. But as long as you took your stratified sample in a random way, then yes, you can generalize. Okay. Before I look at the other ones, here are the three methods for sampling that we talked about. The random number table is the one that we already discussed. Everybody has to have the same number of digits, go through the table, describe it. Random number generator we did in your calculator. And then the hat method, if I wanted to take a sample of 3 of you, I put all your names on a piece of paper, put them in a hat, mix them up, draw 3. You need to be able to do all 3 of those. Sometimes I will say choose a sample using this method. Sometimes I will just say choose a sample. I don't want to go through all 3 of those. On Schoology, there's a document with an explicit example of all 3 so that you know exactly what you would need to hit. Okay. All the other sampling types are not simple random samples. So I want us to understand that. It's not that simple random sample is this big umbrella that everything falls under. That's not the case. We have simple random sample, we have everything else. Okay, so these are all different kinds of samples. They are not simple random samples. Stratified sample is the example that I gave you. Stratified is when we take a simple random sample from each group, and we are going to have homogeneous groups. So within the group, people need to be similar with regard to whatever's being studied. So if I'm studying the amount of time spent on homework, is there reason to believe that freshmen are going to spend a similar amount of time on homework than sophomores, juniors, seniors? That's a stratified sample. So freshmen are similar in that regard, sophomores, juniors, and seniors. I wouldn't split you up into hair color, let's say. Hair color has no relationship to amount of time spent on homework, so that would be useless. You with me? This is not a simple random sample, though. It uses a simple random sample, but it is not actually a simple random sample. There are 2 main benefits to a stratified sample. The first one is that we guarantee representation And not only representation, it can be proportional representation from each group. So like Adam said, if it were a simple random sample, we would have the potential of getting all freshmen. We don't want that. Stratified sample, we could guarantee representation from all four grade levels. And we could have proportional representation. So if there's more freshmen, I could take more freshmen in my sample. The second benefit is that this generally reduces variability. By having proportionality, we are going to reduce variability within our sample. Initially, you're probably wondering why that matters. When we get to second semester and we start analyzing the data, the way it works is you calculate what's called a confidence interval. And so you take a value and you have a margin of error on either side. If we're reducing variability, it means a smaller margin of error. That's a stratified sample. That is by far the most useful or the most used after SRS. SRS is most popular, then stratified. Next one is cluster, where we have individuals in heterogeneous groups we take a simple random sample of those groups and we survey all individuals in those groups. So this is a big difference, but it's a little difficult, I think, to understand from that definition. So your population is broken up into heterogeneous groups. So all of the groups should have a good bit of diversity in them with regard to what's being studied. You take a sample of those groups. So maybe you choose 3 groups, but you survey everyone in the group. At Prospect, I think it's kind of hard to think of heterogeneous groups with regard to amount of time spent on homework. The only thing I can really think of is maybe athletics and activity groups. So if we look at the football team and the dance team and people involved in musicals and plays, those are pretty heterogeneous. So I would take a sample of maybe 3 groups, survey everyone in that group.
Are all the groups going to be the same size?
Not necessarily. Cluster sample, not used very often. Pretty much the only time it's used is when your population is already in clusters. You would never take your population and break it into clusters. You're only going to use it if you already have clusters.
We would use that for like, you think each grade as a cluster for like a color or something?
Sure.
What's the benefit?
Cluster sample, pretty much convenience. That's really it, yeah. Okay, next one is systematic. Systematic is you use a list of individuals in the population. Anybody remember the term for that? The stats term? It's 2 words. Initials SF. Sampling frame, thank you. So it's called a sampling frame. Use a list of individuals in the population called a sampling frame. You take one individual and every kth individual after that. For your sample. So if I had a list of all the of students at Prospect, I might start at the third person on the list and then choose every 50th person after that. What is important about a systematic sample is the list cannot be in any order related to what we're studying. So the list cannot be in any order related to the variable of interest. Again, a systematic sample, really the only benefit is convenience. If you have a good sampling frame to use, it's easy to choose a sample that way. A convenience sample is a sample of convenience. I don't have a better definition than that. It's taking a sample in a way that's convenient to you. So for example, if I wanted to study time spent on homework and I used you as the sample, that's convenient to me. What do you think is the problem with convenient samples?
Doesn't represent everyone.
Right, they're often not representative of the population. And then census, we already talked about. So census, we already discussed. That's when you sample everyone in the population. In your homework, you will have to use these sampling types, either describe them or describe the benefit of them or carry them out. I want to be very clear that what trips students up sometimes is the question will say, choose a simple random sample. And they choose a stratified one instead. Stratified is not a simple random sample. Questions for me before we do a few examples together and then we will take a break. Okay, flip to the next page. We are going to look at some stratified samples or some differing samples. Suppose we wanted to estimate the yield of a cornfield. The field is square and it's divided into 16 equally sized plots, 4 rows and 4 columns. A river runs along the eastern edge of the field. We want to take a sample of 4 plots. Using a random number generator, pick a simple random sample of 4 plots. Place an X in the 4 plots you choose. We're going to do that. Take out a calculator. Everybody remember what button you got to push? Math. Math, and we're going to go to PRB. What does PRB stand for? Probability. And then we're going to choose random integer. We are going between 1 and 16, and we need 4 unique numbers. So I chose, or my calculator chose for me, plot 15, plot 1, plot 2, and plot 12. You can mark those down if you want, or you can mark down whichever ones you have. That is a simple random sample. Adam.
Oh, what if my calculator picked 8 twice?
I would just generate it again and pick the first new number it gives you.
Do you know why my calculator has like 1.000?
Oh, mine has that too.
Yes,
So-
I can look at it later. It's a setting.
Okay.
Okay. Now, next way we could choose the sample is we choose one plot from each horizontal row. This is an example of a stratified sample. So we're going to pick one from here, one from here, one from here, one from here. In your calculator, you are going to choose a random integer between 1 and 4, and again, you're going to do it 4 times. I got 4, and then 3, and then 2, and then 1. And then the last one, we're going to do it again, except this time it's from each vertical column. I got 4, 4, 1, 2, 1. Okay, so like I said, these are examples of stratified samples. You have groups you're sampling within each group. It's not necessarily one, that's what we did in this case. You might sample 2 within each group, so on and so forth. Okay, I told you a stratified sample, within the sample, the individuals should be homogeneous. Which stratified do you think is a better option? Talk to the person next to you. Which one is a better option for a stratified sample?
I think it'd be like the one because one's further
So like the what? Yeah,
Okay, anybody have an argument for the first one or the second one? Okay, we need groups that are most alike within the group. Danny?
The vertical one, because if the river floods, it would result in different,
Yield.
crop.
Exactly. So the key here is that these plots are differing distances from this river. So we need to take the river into account. It might have some effect on crop yield. Here, these groups are all similar to each other, but these plots are not similar within the group. These ones are. In this group, all of the plots are a similar distance from the river. All of these plots are a similar distance from the river. And then we have differences between our groups. So this last one is our best option because the plots are homogeneous in each group with regard to distance from the river. So this way we're guaranteed to get at least one plot, well not at least, to get one plot that's far from the river, one plot that's close to the river. It's going to be more representative of the yield as a whole.
Are we assuming the river, overflows evenly?
Not necessarily, no.
Because potentially there could be like some sort of trench just all along Road 3 or something.
That's true, there could be. If that were the case, then this would be a better option, which you could argue if that's how you take it. That's a little bit of a stretch, but yeah, we're not assuming anything. This is the more reasonable one, but if that were the case. Okay. If you were asked a question like this in the homework or on a quiz or a test, and the question was which one is better and why, this is not sufficient. What is most important about what Danny said is he connected this to the effect of the river on the crop yield. You would need to say that. So these plots are homogeneous in each group with regard to distance from the river. The river could affect crop yield. And that is our response variable. So anytime you do a stratified sample, you have to connect why you are stratifying to the response variable. We're going to take 5 minutes to talk about one last example, and then we will do a break. Questions for me before the last one we're going to do? Okay, there's some questions we're skipping here because we've already talked about them. Find this last one. A school librarian wants to know the average number of pages in all the books in the library. The library has 20,000 books arranged by type, fiction, biography, history, and so on, in shelves that hold about 50 books each. A, explain how to select a simple random sample of 500 books. We're not actually going to go through each of these, we're just going to talk about it. Part A, simple random sample of 500 books. You have your 20,000 books, you choose 500 of them. If you're going to use the hat method, let's say, you write all the book names on pieces of paper, put them in a hat, mix them up, draw 500. Is that practical to do? No, I don't care. That's fine. Doesn't have to be practical. B and C are the ones that I really want to talk about. So, B, how are you going to stratify? We're going to do a stratified sample. What are your strata going to be? And then C, we're going to do a cluster sample. What are your clusters going to be? So what I want you to do is, with the people around you right now, take a minute or two and decide what is the best choice of strata and what is the best choice of clusters. Ideas. So B, stratified sample, we need strata where the books are similar within each group with regard to average number of pages. So what would be one logical way to stratify?
Genre,
Okay, why?
because a biography or a history book might have like a lot of pages, while a science fiction, like it depends on the library, a science fiction book might have fewer pages.
Okay. Genre. It's similar to believe that fiction books are going to have a similar amount of pages compared to history, maybe. History books probably have a lot more pages than fiction books do. What is the benefit of stratifying by genre? Why do you stratify?
Proportional representation.
We get representation of all the genres. It's also going to reduce variability. Cluster sample. Sorry, to clarify with this one, out of the genres, you would have to take a sample within each genre. So you might take a sample of 50 fiction books, and 50 biographies, and 50 history books, and so on and so forth. Cluster.
Could it be like all, like could it be like 49, like maybe
Sure.
all be 50 or like it can be different?
Can be different, yeah. Oftentimes it is, so if there's more fiction books, generally you pick more out of that strata. Cluster sample. Within clusters, the books should be have variety with regard to number of pages. So what would your clusters be?
A bookshelf?
Bookshelf.
Would bookshelves work? Because it says the bookshelves are type.
I knew you were going to say that. Not the best option. I agree with you. In a library, books are arranged by type, so yeah. This is our best option, but still not great.
Could we go with last names of authors?
Sure. Sure, author last names, that's probably a better option. If we go with the bookshelves, let's just assume that this library is crazy and the shelves are just arranged in a random order.
It says in the question.
It's okay, bro. It's just
Thank you, that's what I'm gonna do, I just needed to find it. Okay, like imagine it's like a My Little Library, but it has 20,000 books, okay? So they're just completely random. So you have these bookshelves and they just have random books on them. Here is the difference. In a cluster sample, whatever shelf you choose, you take all the books. So we would need 10 shelves. So we would take a random sample of the shelves, choose 10 shelves randomly, but then take all the books on that shelf. Okay, again, pretty much only done for convenience.